been given a table of values this time that shows the slope and the concavity. And so we're going to use this table to find where we have relative maxes and mins. So here we can see a max on the original function, and on the derivative we have a 0, where the derivative changes from positive to negative. So we're going to look in our table to see when we have a 0 for our derivative, and when we change from a positive number to a negative number. So this must be a max. And then we're going to look to see if there is any time where the derivative changes from negative to positive, but here you'll see positive, undefined, and back to positive. So that must be a plateau. So there was only one max at x equals 2. Here's our x value of 2. Now we're going to look for the interval on which f of x is decreasing. And so we'll go back to our main curve and we'll see a decreasing original function when our derivative, blue, is negative. So we're really looking for the first derivative to be less than 0 or negative. As I go into my table, here I have negative numbers, and here I was 0. So you can see that I was 0, and then I went negative. So everywhere from 2 and beyond was where my function is decreasing. I'm decreasing all of that time. So our interval will be from x equals 2 to infinity. That's where I'm decreasing. So now we're going to look for concave up. We'll look for our original any function. We're concave up here, meaning our derivative is climbing or increasing, and our second derivative is positive. So that looks like the easiest one to look for. Let's look for a positive second derivative. Well, here I see positive values. Everything between these 2 points is also going to be positive. And everything between my undefined value and 3 will be positive. So that means this is when I am concave up, because my second derivative is positive. So we'll say we were concave up from negative 2 to 1. And now we'll try to make a sketch of this graph. So again, with positive derivative, we're increasing. More positive derivative, we're increasing. Negative derivative, we start to decrease. We've identified that. So let's just draw that. We increase all the way until our maximum at x equals 2. And then we start to decrease. Now we'll look at our points of inflection. Our second derivative changes from negative to positive at negative 2. So that must mean at negative 2, I have a point of inflection. And I have another one where my second derivative changes from positive to negative at 1. So I'm going to have a point of inflection there. And now I'll look at my concavity. I was increasing, but concave down because I have a negative second derivative. So I'll increase, but concave down. And then I have more increasing, but now I'm concave up. Then we have our point of inflection, and we're back to concave down, and we have our max right here at 2. I'll put my max up a little bit more, and I'm concave down to 4. That could be a sketch of the original g of x based on the derivative and second derivative.